Okay, hello everyone. In this video, I want to show how we can run the clustering algorithms on a sample dataset. And in the assignment 8, second question, you will use same exact process to do your assignment. So the first part is about measuring the distance because clustering is all about similarity and the distance between different instances or records. So I want to show you three process, and the first one is on how to measure the distance between records. So in this process, first of all, we imported the data. Then first, let me show you the data itself. It's the utility data of some companies in different locations that we already talked about in the class. So companies are in different utility companies are different locations. They have some fixed costs, ROR costs, and sale, whether they are using a portion of the nuclear energy and other um, features about these companies. So this is our data set, and now we set the role of company as ID. Then we will select these three um, features to do our analysis and measure the distance. So you remember that we had two types of normalization. First one was min-max scalar, and here we are using the second type or Z transformation or standard normalization. So Z transformer is the same as standard normalization, where we subtract from the mean and divide by the standard um, deviation of the data. Then we copy the normalized data and send first as request set and also as the reference set. So cross distance measures the request set with the reference set points and outputs the result. Let's run the model and see what happens. So in the cross distance tab, we can see that it gives us different labels. So let's yeah, sort the data based on one specific company, Arizona. And so of course the Arizona distance is 0, and then Arizona with Oklahoma is this, and we have different distances. So you know that this distance are normalized, and we can sort the different companies from different geographic location with different distance. And this one simply shows the normalized data, and this one is the original data. So we filtered the data, and we wanted to just output the sales and fuel cost of these companies. But the original data set had more than two features. So this was the first part of clustering, and the basic algorithm, which is measuring the distance, to implement the more complicated clustering algorithms. So let's look at the second process, which is uh, about clustering using the k-means clustering. So we imported data set and then set the company as role, as ID. Then in normalization, we applied the Z transformation, which is standard normalization. Then we copied the data to send to performance and to the clustering algorithm. So the clustering algorithm is an operator which uses the k-means. So you know that we had two types of clustering algorithm, hierarchical and the k-means. We are using the k-means in this example, and we want six different clusters as output. And since the k-means is a um, repetitive algorithm, it has different rounds. So in each iteration, it improves the clustering result. We set the iteration to 50 rounds, and then we the distance measure or measure type is set to numerical measure, and we are using the Euclidean distance um, as the numerical distance type. Then uh, we are sending the output to make two copies because we want to visualize our clustering with this operator, and then we want to see the performance criteria. So let's run the model and see the um, result. I wanted to yeah, explain the performance criteria as well. As you know, we have two types of measures or distances in clustering, intra distances and intercluster distance. So when the points inside the cluster are closer, that one is desirable. And when the clusters are far from each other, that's also another criteria that we are looking for. So the Davis-Baldwin measure is a measure that mixes these two types of distance, and it gives you a unique measure to compare between different clustering result. And the low value of the Davis Baldwin measure is desirable because it means that with low intra-cluster distance or high intra-cluster similarity and high intercluster distance, we'll have a low Davis-Baldwin index. And that one is considered as a successful clustering algorithm. So with this in mind, we can now run the model and see how is the result. So the first step of the run just gives us the normalized data because we had a breakpoint after normalization. Then we run the model completely and see the normalized data and its clusters. Beside the data, we had 22 records, and now it shows that which cluster each one of these records falls into. And in the second one, we'll see the performance criteria. It shows the within centroid distance and for example, in cluster 0 within centroid distance is 3, and then we have 2, 3. For two clusters, cluster 3 and 5, our within centroid distance is 0 because we just have one cluster. So you can check this here. Cluster 3 is only in Y, and cluster 5 is only San Diego. So we don't have that much within centroid distance. And this was about the performance criteria. Then we'll see the result of clustering. We had 6 clusters. All of the 22 items are clustered into 6 category. And then in the folder view, we can see each one of these records in different clusters. We can have the graph view and see the names of each items in the clusters. Then the central table is important table, and you will use this in your assignment. Shows you the characteristics of the centroid of this six cluster. So the cluster 0 has these features based on our initial feature or attributes. Cluster 2 centroid is this point, and so on and so forth. In the plot chart, you can see the profile of each cluster. For example, cluster 5, which is shown with the red line, has low fixed charge, low ROR, a little higher costs and higher load factor, demands there, and sale is relatively low. Then average nuclear and fuel cost is relatively high. So this is the characteristic or prototype of this cluster, and you will extract the same for other clusters. And in the visualization, which is a specific operator to better visualize the profile of each cluster, you can see some very good information about different clusters. Then you will see the heat map of each cluster, which shows the different feature value for each clusters in a summarized view. We have same chart as the profile of each cluster, and this shows the centroid table in a different view. And then you can see the you can see the scatter plot with different colors. All of these 5 clusters are shown. So this was our second process that we need to learn and use in our assignment. Then the utilities C k-means clustering is the final process that I want to talk about, and you'll directly use this one in your assignment as template. These parts are basically similar. The only difference is that here you remember the normalization algorithm or normalization model to denormalize your data in the future. I will show you how it works. It's just a operator that remembers the model that normalizes the data, and then it recall later to use in different operators. And we make a copy of normalized data. We'll send to the performance, and then one copy to the clustering. The clustering algorithm is k-means, and maximum bronze is 10, and we are using the numerical measure and set the Euclidean distance as a distance function. And we will have the clustering model here. We'll make 3 copies, send to the performance, and we'll send to the visualization, and send to extract the cluster prototype. So this operator here, basically the purple parts are the difference between process B and this process. So this is new, and we will focus on this part to explain what's going on here. So this section is basically same, just visualizes the clusters. But here you have the cluster prototype, which is shown by the centroid of each cluster. So basically, this operator gives you the centroid, and then this recall denormalize the data. And in apply model, we basically denormalizing the cluster points and converting them to the original feature scales to better understand the result of clustering. And in here, we again doing the same, denormalizing our data set and just running the denormalization on the original data. In here, we are denormalizing the clusters and sending to the output. And in the lower section, we are denormalizing the original data and sending the output to the result. Let's run the model and see the result. Again, we have the original data with the cluster here because we denormalize the data. That's why we are observing the original data. Then in the performance vector, we have within centroid cluster, same as the previous one. Let's look at the other outputs. So other important result here is the profile of each cluster or centroid in the original scale. So it's not normalized, it's the original scale, and you can get the idea of centroid of each cluster in your original scale. So that's the useful information, and it's different from the second process that I just showed you. And we have the result of clustering, and we can see different outputs, same as the previous one. And let's see information in, but this one shows you the normalized cluster information. So these are the normalized centroids, but the other table, example set apply model result, shows the cluster dimensions or cluster points in the original scale. Okay, so this was a three process that we had in clustering algorithm. You will use this process to do the second question in the assignment 8. And so let me know if you have any question on this. Thank you.